Alright, so these are the answers for the practice problems. I'm going to predominantly use the map to Moleville to explain how these problems are done. Of course, you can use dimensional analysis, and if you'd like to see that done, then please make sure you come see me and I'll gladly guide you through that. So our first practice problem is looking at you have 7.50 moles of sodium bromide, and that's going into your swimming pool. How many grams is that? Well, to get from Moleville to Mass City, from moles to mass, we need to multiply by the periodic table molar mass, and that's what 102.9 is for sodium bromide. Sodium is 23.0, bromine is 79.9. So you add those together, 102.9. When you multiply those two numbers together and round for the measurements, three numbers in my measurement, three numbers in my answer, that's how I get 772 grams. The next question, if you are given 22.2 grams of zinc chloride, how many moles is that? Well, to get from mass to moles, we have to divide by the periodic table molar mass, and that's what 136.4 is for zinc chloride. Zinc is 65.4, and two chlorines, 35.5 plus 35.5. That's how we get to 136.4. So when I do the division, that's how I end up with 0.163 moles. Again, three numbers in my measurement, so three numbers in my answer. The zero you don't have to have. You can if you want. It's just a placeholder there. The third question now is going to bring us between Particletown and Moleville. So how many formula units are in 36.5 moles of lithium nitrate? So we just take the 36.5 moles times the chemist's dozen, Avogadro's number, and when you do that and you properly enter it into your calculator, you should get the 2.20 times 10 to the 25th formula units. So again, the first two questions used the periodic table to get us between mass and moles. That last question used Avogadro Avenue to get between particles and moles. And that's what the fourth question does as well. If there's that many propane molecules in a torch, how many moles is that? Then we simply divide by the chemist's dozen, 6.02 times 10 to the 23rd, and that's how we get the 0.140 moles. The last two questions are going to do double duty, two steps, from mass to particles and particles to mass. So we have to go through Moleville, so we're going to have to involve Avogadro's number and the periodic table. So question 5, how many atoms are in 555 grams of technetium? Well, first I take the 555 grams, divide by the periodic table, and that'll tell me how many moles there are. And then I multiply that by Avogadro's number to get us to the appropriate number of atoms, 3.41 times 10 to the 24th. And the final question, the mass. How many grams are there in 7.66 times 10 to the 23rd molecules of phosphorus trichloride? So first I have to take those molecules, divide by Avogadro, tells me how many moles, and then I need to multiply that by the periodic table mass. And so again, PCl3, phosphorus is 31.0, and then 3 chlorines, 35.5 each. Add those all up to get the 137.5. When you multiply, that's how you get the 175 grams. Again, making sure we've got three numbers in that part of the measurement, so that's why we have three numbers in our answer. Hope that helps. Again, if you want to see dimensional analysis, please come see me and I can work that out with you.